My name is Margaret Scheiner. I'm originally from Maynard, Massachusetts. It's a very small town, but the state crime lab is there, which is cool. And it's also pretty close to Concord, where the Revolutionary War started. So we have our own little history. So my research is, in brief, to make a self-healing airplane. And so we want an airplane that when it flies through a hailstorm and gets hit by the hail, will tell the pilot exactly how much damage it sustained, where the damage is, and how bad it is, and then also fix that damage. So even if it was bad, you don't have to worry about the plane's stability or making it to the end of the flight or doing an emergency landing because the plane just fixed itself. So it's based on research my advisor's been doing for a few years, and we're a structural health monitoring group. And so that's damage sensing of if you have an airplane or a bridge or a building and something happens to it, a computer somewhere will tell you if it was damaged and how bad it was damaged. And we are doing it using material that's triboluminescent, which is not a common term, but it is a really common thing. So things like sugar and jade are triboluminescent, and what it means is that as you break them or create friction through that material, it emits light. And so then when damage happens, we have a light signal saying, hey, damage has happened. We can convert that pretty easily to electricity, and then we have a computer signal saying, hey, damage has happened. Sometimes it just does not work. So one component of triboluminescent materials is that you can get different colors. So you can break one material and it emits red, another one emits yellow. And so to see where damage is happening, it would be great if we could tell which material was emitting. And that's actually a lot harder than it sounds like it should be. So we've had 3 different meters to try and record that light. But since the light's very brief, it only happens during the impact, and it's also not super bright, it's really hard to record. And so we have spectrometers and different kinds of cameras to try and record it. And we can, in monochrome, we can tell that it happened, but not so much what color it was. And so that was 6 to 8 months of just trying stuff that would not work and trying to find something else that would work, and it doesn't work. So there's someone else in my research group is working on making a photodetector that will respond differently to different color lights. So we couldn't find an existing device that would work for this, and now someone is making one. So it should be a project that actually happens, just not within the scope of my dissertation. The number one thing is that you can do it. There's no reason that if you're considering doing engineering that you should feel like you can't do it. It doesn't matter what your background is or what gender you are or any other features about yourself. If you want to do it, you have the motivation, then you can absolutely do it. I visit high schools and talk about engineering, and my favorite thing to say is I still can't multiply by 8 in my head. So really, like, if you're struggling with math, you can still do engineering. So you just have to find the feature about it that you like and what motivates you, and there are people out there who will support you. I actually first learned about engineering in high school when my guidance counselor said, maybe you should consider engineering. And I didn't know it was a thing before then, or not a thing that I would ever do. So it's pretty happenstance of, oh yeah, maybe I'll do engineering. And then a big thing that supported me throughout undergrad and also still now in grad school is the Society of Women Engineers. And they have programs for middle schoolers, high schoolers, undergrads, grad students, professionals, and they connect people from all these different positions in life, and they have outreach programs where you can learn more about engineering or help others learn more about engineering. And I've done a lot with them and for them. So there are many organizations like that for engineering and also science in general and every other discipline. There's a group out there that wants you to succeed and has resources that are usually free and available to you to use. I wouldn't have gone to grad school if I had to pay for it myself. So I wouldn't be here. The student group I started wouldn't exist. My research would never have happened. I never would have met the people that I've met. I wouldn't have the opportunities that I have, like this summer I'm going to Germany to meet with Nobel laureates. It would never happen if I wasn't in grad school. So what my life would be like, I would probably be in finance based on my undergrad degree and doing pretty much the same thing every day. So having a good relationship with your advisor is definitely important, or for me, it's important that I have a good connection. I don't think it's a necessary component of every single student's program, and part of that depends on the student and also on the advisor, where, like, as a professor one day, I might not be able to connect with students a certain way that works for them. So there are different ways that a good connection can look, I guess is what I'm trying to say. So it's not, like, I don't sit down with him and talk about what I do on the weekend. And some advisors do that, and that's fine. But it's just not part of what we do. And I already forgot what the question was. Good advice probably looks different in different fields. As an engineer, specifically as a female engineer, advice I would give is you don't have to pay for grad school. And that goes for a lot of other minorities, not just gender minority, but there's a good chance that someone out there is willing to pay for you to go to school. A lot of employers for engineering will pay for a master's, as long as it's relevant to what they're doing. They want to support you to do better for them. So I don't know what it's like in other fields, but in engineering, a lot of employers will pay for a master's and sometimes a PhD, depending how long you worked there. And then I went straight into a PhD program for my bachelor's, and I'm not paying for my education either. So all of my tuition is covered by my research advisor, and I also have an assistantship position, so I get paid to go to school, which is pretty great. And then on top of all of that, there's also everything that AGFA supports, of applying for external fellowships and awards and getting more money to pay for school. So I'm a different person now than I was 4 years ago. When I started grad school and I had to meet with my advisor, I would email him and then maybe run into him in a hallway and be like, oh, hey, can we meet? And it would eventually happen. Now when I need to meet my advisor, I show up at his office and I email him, and I email him a calendar request, and I send him a follow-up email, and I show up at his office and I call his cell phone, and I hunt him down and I make it happen. So being a lot more proactive about following up with people, and just, if I want to do something and like they want to do it too, and there's a reason for us meeting, then I'll make it happen. I'll get a meeting to happen. And that is not something I would have done right out of undergrad. And a big part of it is you have to do that in grad school to some extent, of like, your research is your research, and you're the one who has to make decisions and plan things and schedule them and get them done. And so doing all of that for research stuff is spread out into meetings, and if I want to go to an event and I see it happening, I'll like plan ahead and make sure that I can get there. Yeah, so a big thing is knowing that it exists. When I was in high school, I definitely wasn't thinking, yeah, I'm gonna go to grad school for another 5 years after undergrad. I just realized that engineering was a thing in high school. I wasn't planning to do it indefinitely. So watching this video, learning about AGFA, knowing that it's a thing is a really good step. And then honestly just doing some Google searches of things you might be interested in and seeing what kind of jobs there are out there. So one great thing I like about engineering, especially industrial engineering, is it's about doing things better. And industrial engineering is really the how do you do things better, how do you do them more effectively and more efficiently and for cheaper. And so what industry does that apply to is absolutely all of them. So as an industrial engineer, you're not studying mathematics and doing pure mathematics or doing finance kind of stuff. You're studying a method, and then you can apply that to the food industry or sports or automotive or whatever thing that you like can be your career. Yeah, but knowing what's out there is a good step, and searching. There are a lot of posts, like blog posts and stuff, that'll list different career options and then required degrees. So not every career requires a grad degree. There are lots of famous people out there who went to school and dropped out and are still famous because they were successful at whatever. But there are a lot of cool things out there that you need to have some kind of additional proof of, you know all these things and you know how to do this, or for a PhD, you know how to do research and come up with your own ideas and follow through and like learn something new. So a hard semester was one where I was doing my qualifying exam for my PhD program, and I was also TAing and doing research and trying to get a review paper out as one of our publication requirements. And also that summer my grandfather died, and know from experience that I'll start crying if I think too much about that. But a really good thing that came from it was after the semester was over and I got all the things I was trying to do done, I told my advisor, like, oh, by the way, this was also something that was happening. And his reaction was just like, oh, you should have told me, like, we could have done something or worked together or found a way to make it slightly better. But the way that works best for me is just like to do stuff and have things to focus on and get done. So it worked out the way it did and everything went fine. But it's really nice to know that he's really supportive. And if anything else happens, like, he's going to be supportive. And a recurring theme in my PhD program is that he wants me to succeed. And that's a great quality in an advisor, and I think that's really something you should look for when you're looking at different programs or considering it, is you want someone who wants you to get there. And that doesn't mean that he's always happy with me, because part of getting you there is to motivate you and get you to do things. But for doing things differently, I don't know that I would. Even like knowing what I know now, I've done pretty well. So yeah, maybe being a little more focused on my research to try and get that done sooner. I'm planning on graduating in my 5th year, which isn't weird for engineering PhDs, but it's possible to do it in 4 years. So I maybe could have graduated this year if I did something different, but I'm not even sure what that thing would have been. So I don't know. I think I did it pretty well.